So this is my midterm extra credit. I don't have the exact questions that I used, like wrote the workout for on the exam, because I kind of used scrap paper and it was all over the place and I have no idea where it is. And I do have the examples and like questions that I solved by myself for the exam that I can explain to the best of my ability. I did some of the questions like over and over because I didn't understand them, but now I think I have somewhat of an idea. For the first question, it asks for like the initial value problem. So this was the example I used, and then this is the part that I did by myself. So you have to rewrite the differential equation in standard form, the standard linear first order, and then the px is equal to 2. So the integrating factor is calculated as this here. So you multiply the standard form equation by integrating the factor e2x, and then you get this part here, which gets you to here. And then you integrate both sides by x, and then you solve for y. So this is what you would get when you solve for y. And then when you use the initial condition of y0 equals to -1 to find the value of the constant c, you would once you find that value, that constant c, so here it tells you that y0 equals to -1. So then once you find the last part of the, like, what form you want of the equation, which in this case would be it would be, once you solve for y. Yeah, I do have notes on the side. I did go through every problem and I wrote my thoughts out on here so I don't mess up during the video. But yeah, so once you substitute for c, and we know that the initial given condition here is -1. So once you plug that in, you should get the value for c, which in this case is -3. And then you substitute the c equals -3 back into the general solution. So that's how you get yx equals to 2 x minus 3 e to the power of -2x. And then I did another example, but I did it on my own to see if I would get it. For the second question, it says to find a general solution to the given differential equation, which in this case is 15y plus 7y minus 2y equals 0. So you turn that into the you convert this into the auxiliary equation, which is 15r squared plus 7r minus 2 equals 0. Then you have to use the quadratic formula, in which in this case you substitute the values here. So a equals 15, and then b equals 7, c equals -2. And then once you plug those values into the quadratic equation, you should get this, which is like the roots basically. And once you get these, you have to solve for negative and positive roots, which in this case we got 1/5 and then 2/3. And then you plug it back into this equation. So this would be the general solution. You would just plug this back in as the exponents, and you would get yt equals to c, this right here. And I did it again by myself just to see if I could find the roots on my own, but I got the rest of it, so that's why I didn't complete it. I understood the rest of it. So the third one is to solve the initial value problem. So in this one was pretty simple. I did get a little confused on where to plug in the values that I found, but so basically to solve for the initial value problem, this is what we started with. So x to the 4th, you're gonna turn that into, so we put the y in -2 and we moved it over to this side, so that would be our dx. In this case, in this situation, would be y minus 2, and then the x to the 4th would stay here, and the dx would move over here. So basically switched it over. And then you put this into this form, and then once you do that, we end up with ln absolute value y minus 2 equals to x to the 5th over 5 plus c. And then you would replace the 4 since y 0 equals to 4. You're going to substitute the y for 4. And then x would be 0 in this case. So once you solve for that, we end up with ln 2 equals to 0 plus c, and then c equals to ln 2 once you solve for c. So once you get that, you basically, so the 4 here, we're gonna, to find the derivative, you would add a 1 to get 5. So then ln, and then absolute value bars, y minus 2 equals to x to the 5th over 5 equals to ln 2. So this would be the solve initial value problem if y 0 equals to 4. And I did it again on my own as an exam. This was my practice basically. So all the blue is my practice. For number already did that one. Number 5, classify the equation as separable, linear, exact, or none. For this one, every time I did the practice exam, I got either none of these or exact, as like 2 of these options were the answer, but I didn't understand how they were different. So I did do my research, and the first thing you do is to check for separability. So x and y can't be isolated into the form of fx dx plus gy dy equals 0, which is this. So because of the xy terms, so you check for linearity. Sorry. So you just check if it's linear. Sorry. So non-linear. So in this case, it would be non-linear because it has independent and dependent variables with an exponential form. So exy, and then derivatives must be to the first power, not multiplied by anything else. So in this situation, the derivatives are multiplied by numbers that are not 1. So so the mxy is basically this fxe x to the y plus 4y, and then the nxy, so like x comma y would be 5, this part, so fye x to the 4th plus 4x. And once you you convert these, so if for this one it would be 5x squared exy plus 4, and then for this one would be 5y squared exy plus 4. So those in this case situation would not be exact. So it would be none of these. So these two, yeah, pretty sure that they would not be exact. This one was a little bit confusing for me, just to test every part, to check for exactness and to test every option. This one was a little bit tedious. So for number 6, I found it pretty simple. It was just the auxiliary equation for the given differential equation has complex roots, so find a general solution. This one is pretty simple because all you have to do is convert it into the auxiliary equation and then plug it into the quadratic formula. From there you find the roots, so 4 plus or minus 6i, and then you plug it into this form, in which 4 is plugged into the 4t part of the equation, and then the 6 would be attached to the t on both sides. For cosine and sine, c1 and c2, it would be 6t and 6t. So that one was pretty simple for this specific question because the form was the same for every example. It's just that the numbers were different. For number, is there 7 on it? Yes. Okay, so this one was also pretty simple. Determine whether the equation is exact, and for here I did the same thing as here, where I did check for exactness, and it did prove to be exact because the implicit, so it's called the implicit solution. So the implicit solution in the form, fxy equals c, and it was exact because of the result. We got x cubed y plus 5x minus 7. And this proved that c, in which c was an arbitrary constant. So that one was also pretty simple. There were some of them that I had to really this number 11 was one that I had to do over and over because I didn't understand. I kept getting different answers than what the examples were telling me. So like for this one, it says determine whether the function y1 and y2 are linearly independent on the interval 0, 1. And then this is the equation that we were given. So y1 equals e3t, and then y2 equals e negative 6t. So in this one, I did have to read this chapter again, because I know this homework for me personally was, I mean, it was simple, but it was kind of hard. But again, you test for exactness, so you equal both of them to each other. So in this case, it would be 3x squared, it would be y1, like the derivative of y1 would be 3t, and then the derivative for y2 would be negative 6e, and then to the power of negative 6t. And then once we did that, once we used the Wronskian formula, I'm not sure if I'm saying that right, in which we solve for yt, and e3t and e to the e negative 6t, e3t, and then the derivative, so negative 6e, negative 6t. Once those were set to each other and multiplied, we ended up with wt equals to negative 9e minus 3t, which means non-zeros for all, and then real values of t, interval 0, 1. And then because of the exponential function, e3t would always be positive, and with the result that we got, wt was not equal to 0 on the interval. So that means that the functions are linearly dependent on 0, 1, because of the fact that y1 is not a constant multiple of y2, and the result we got when we used the Wronskian formula, those prove that the functions are linearly independent. For number 9, it was that one also was pretty simple. So the differential equation is given. Classify it as an ordinary differential equation, OD, or partial PDE. So in this case, we got the equation was dy over dx equals to y, and then 4 minus 9x dx equals to x. 3 minus 9y is right there. So this proves to be a nonlinear ordinary differential equation, because if it was linear, you can write this in the form of dy over dx plus pxy equals qx, but in this situation you can't. And since this equation cannot be rearranged into this form, this is considered non-linear. So this is how I got that answer. And then the order of the differential equation is 1, because the order is determined by the first derivative, which in this case is 1. And then independent variable is x, dependent variable is y. For number 10, once again, you're converting the y plus 49, and you're converting the first part of the equation into auxiliary form. So it's saying to use the method of undetermined coefficients. So the first step I did was to turn the first part of the equation, so y plus 49y, and turn into auxiliary form. And with this form, we could find the roots, which in this case, once you find the square root for 49, you would get 7 and 7, so it would be 7i minus, and then negative 7i. And once you get those roots, we're able to determine that once the equation starts with ypt, it would be cosine and sine, and then we have our from 3, 3, 2, 1, 0, and then from b, 3, 2, 1, 0. And we just needed to know that the roots were 7, so cosine 17 and then sine 7t. This makes the equation complete. For number 11, this one was a bit tough. I had to do it multiple times, but the first thing I did for the Brown solution problem was I basically wrote down all of the vital information, so what I was given. So the 6 liters per minute, and then the 100 liters, 0.2 kg, 0.02 kgl, and then the 0.01 kgl. And I split this up based on the rate in, rate out, dA over dt, dA over dt. And I set those out first. So the first thing I did was the rate in, and I converted that by multiplying the 6 LM times 0.02, which I got 0.12, because and this is part is what gives you the vital information to solve the rest of the problem, is what I learned. So, and then the dA over dt form would basically be 0.12 minus 0.6, because we did multiply this by 100 to convert it into 0.06. And then dA over dt plus 0.6a equals 12. We were able to plug in our what we converted into this equation, and we were able to isolate the 0.12, in which we were able to plug in the E 0.6 dt, and then E equals to E 0.6 t. And then for AT, we were able to plug in the negative 0.6, so it will be 2 plus CE negative 0.6 t. And then once we did that, the 1.8, we're able to because it would basically be 2 minus the 0.02, in which this case would be 1.8. So 2 minus 1.8 e negative 0.6 t, and then the 0.01 that we have up here, we would also convert that and multiply that by 100, and we would get 1 kg. Once we plug that into the equation, and we would set the rest of the equation to 1, and then negative ln 1 over 1.8 over 0.06, which equals to 9.79644. You round that to 9.80. So you can, this part of the equation, you can simply just plug it into your calculator. And I did remind myself that this, because I kept forgetting some of these names were pretty long. So this form is actually called the first order linear non-homogeneous differential equation. So my issue was that I kept getting a different number at the end than what the example was giving me. So I did try again. This time I did it on my own, and I did get the correct answer. And then I did it again just to double check. But yeah, and then number 12, it says determine whether the given function is a solution to the given differential equation. In this case, it's delta equals 4e to the power of 4t, which equals to 3e 5t, and then d2 delta over d2 t2 minus delta d delta over dt plus 4 delta, which equals to negative 20e 5t. So this one, I did at first guess. I did at first guess if it was a solution or not, but I did understand that we had to find a solution. We must. This one was a little bit hard. I'm pretty sure I got this one wrong in the exam. I did I did it. I got the right answer, and I second guessed myself, and I wrote the right answer on paper, and I said it doesn't look right, so let me just try again. So this one, this is just an example I wrote down, and on scrap paper I did it over and over and over again. I still didn't understand it. So this one, I'm not sure if I can explain. This is just an example I wrote down. All I know is not a solution, and I'm not sure why. And then this, I reminded myself that in this specific problem, they were not equivalent, and I did search videos and stuff on this specific question because I was very, very stuck on it, but I just could not figure it out at the end. But for number 13, this one was pretty basic because I circled this because I know this part was significant, because this was going to be in our end result as well. So negative 2e to the negative x, dy over dx plus 2y equals 2e negative x. You convert that into this form, in which dy dx plus 2y is multiplied by e2x on both sides, which isolates that. And then we have d over dx times e2x to the y equals 2ex. And you just keep, and at this point, you just keep converting it to a point where we have we can plug in the 5 into this last equation that we get, which is 2e negative x plus ce negative 2x. And then once I plugged in the 5 to solve for, and then set both x's to 0, I did end up getting 3. So this negative 2, the 2e negative x, we do end up bringing it down, and then we replace the c with 3, because that's what we solved for, then 3e negative 2x, and that would be our end result. I hope that made sense. I did try my best. I was having a little bit of anxiety about having to take a video. I did try my best to find the scrap work, and I tried my best to explain. I did have my notes here, so I know what to say, and this video is not too long, but it did end up being too long. But yeah.